Okay, so f prime of x is 1 divided by 2 the square root of 25 minus x squared times negative 2x, or negative x divided by the square root of 25 minus x squared. So f prime of 3 will be negative 3 divided by 25 minus 9, which is 16. The square root of 16 is 4. I also have to find f of a, which is f of 3, which is 25 minus 9. That's correct, yes. So now the linear approximation will be f of a, which is 4, plus, I should write negative 3/4, and x minus 3. Is this okay? So I replaced f of a by 4. I replaced f prime of a by negative 3/4 and x minus 3. I distribute to find the line. So negative 3/4 x. Negative 3 over 4 times negative 3 will be positive 9/4 and plus 4. So 16 plus 9, 25. So the linear approximation, the linearization is negative 3/4 x plus 25 over 4. Near 3. So if I use the function to evaluate at 2.9, or I use the line to evaluate at 2.9, it should not be a big difference. Sure. But if you want to use this line and evaluate the function at 15, it's not going to work. So you can replace the function by this line only close to 3. Is this okay? We can illustrate that. If you have any doubts, we can go to y equals and clear everything and put in the square root of 25 minus x squared. And we can put in negative 3/4 and x and plus 25 over 4. And let's go to second and table. And second and table set first. So second and table. And let's see what happens if I plug in 3. Nice. Of course, it's the slope is the tangent, right? They touch, and at that point they have to be the same. So let's say 2.9. This is the actual function, and this is the approximation, which is the line. Let's say at 3.2. So this is the function, and this is the approximation using the line. Let's say at 10. Oh, of course, because it's not defined. So
negative 3.
okay, negative 3. That's a good one. See, it's huge. The line does not approximate that far out. So the line can be used very near 3. The answers are very close. Good. Does this make sense? Other questions here before I just talk briefly about 3 more functions? You can say we need more. We don't have enough. Well, we do have enough, but these are 3 important functions. And I'll show you what they are used for. And this is the last section before test 2. So test 2 on Monday. And since today's the 15th, yes? You mean this one? Yes. So Monday, so 15 plus 7. Still 23? Good. So chapter 3. Okay, so let's look at 3.11, hyperbolic functions. Hyperbolic functions there are 6 hyperbolic functions and their inverses, and of course 6 derivatives for the functions and 6 derivatives for the inverses. We are only looking at so let me first of all let me tell you what they are. They're all based on exponential functions. So one is e to the x minus e to negative x divided by 2. In short, they named it hyperbolic sine. Hyperbolic sine, but it's e to the x minus e to negative x. And e to the x plus e to negative x divided by 2, what do you think this would be? Of course, yes, hyperbolic cosine. And of course, there is a hyperbolic tangent, there is a hyperbolic cotangent, hyperbolic secant, hyperbolic cosecant, and their inverses, and of course, 12 derivatives. So hyperbolic tangent will be e to the x minus e to negative x over e to the x plus e to negative x. That's all I need you to remember, and the derivatives of these 3. So let's prove one or the other, either sine or cosine. Not with the definition, it will be just one line with the formulas, the differentiation rules that we know. So which one would you like to prove? Sine prime, hyperbolic sine prime, or hyperbolic cosine prime?
Sine.
Okay, fine. So hyperbolic sine prime is nothing else but e to the x minus e to negative x over 2 prime. Yes?
For the notation, the sine hx is the x, the variable of h of x.
No. So hyperbolic sine of x.
Okay.
So the name of the function is hyperbolic cosine, and x is the variable. The name of the function is hyperbolic tangent, and x is the variable. Better? Very good. So I will keep 1/2 in front, and I differentiate the inside. E to the x prime is e to the x. But when I differentiate e to negative x, is e to negative x times the inner function prime. How much is the inner function prime? Times the negative in front. So what do you think this is? Look carefully and say, oh, it's, say it again. Very good. Hyperbolic cosine. So hyperbolic cosine x, you would expect it to be correct. It's not going to be negative, though. That's the only difference. It's positive. So both derivatives are positive. Hyperbolic cosine and hyperbolic sine, when we differentiate them, you get the other one, but with positive. And of course, no secret about hyperbolic tangent prime, no change. What do you think this would be?
1 over
Hyperbolic secant squared. Although I would like to put the power after h.
So the derivative's same exact for cosine, hyperbolic, and cosine. Hyperbolic?
So hyperbolic sine is hyperbolic cosine. Hyperbolic cosine is sine, but not with a negative sign in front of it. Is that clear? When I differentiate sine, I get cosine. When I differentiate cosine, I get negative sine. But this is not the case here. So when I differentiate sine, hyperbolic sine, I get hyperbolic cosine. When I differentiate hyperbolic cosine, I get positive hyperbolic sine. And when I differentiate tangent, I get secant, hyperbolic secant squared. That's the only difference from the regular trig functions. And the applications are very interesting here. on page, let me just show you. Ocean waves, and especially this is an interesting application because you see it everywhere. A cable between two posts, or between two poles. It can be a phone, which we don't have that anymore, but it's still available in different countries, and I think in a rural area we still have this possibly, but not necessarily. It can be just electric poles or electric cable. It doesn't have to be phone. So the best function was a hyperbolic function. This is the graph. This is the graph of hyperbolic sine. This is the graph of hyperbolic cosine. That's why this is a best option for something like this. And this is, look at that. Isn't that interesting? This is a hyperbolic tangent. And it's all based on exponentials, nothing else. Okay, so let's look at few derivatives here. I'm not going to ask you to memorize anything else. So on page 263, let's look at a couple and then start reviewing. So let's say 31, f of x.
What page again?
263. So x hyperbolic sine minus hyperbolic cosine. So we're asked to find the derivative of this function. Can anyone dictate?
1.
Correct. Hyperbolic sine plus very good. X hyperbolic cosine, and then minus hyperbolic sine. These two go away, and the answer is x hyperbolic cosine. Very good.
Where'd you get the plus x from?
So these are two functions, function 1 and function 2. The first function prime times the second function plus the first function times the second function prime. I copied the sine, and cosine hyperbolic prime is sine. So these two go away. So I have left only x. Is that better?
Oh, yeah.
Very good. Okay, so let's look at 35, in which we have y equals e raised to hyperbolic cosine 3x. So y prime would be e to u, e to hyperbolic cosine 3x times very good, hyperbolic sine 3x times very good, awesome. Always remember the chain rule, only product, no addition, subtraction. Any questions here? Yeah, so let's look at the
Well, I guess how we answer
I'm sorry?
that.
That's it? That's it. You can rearrange it by putting 3 in front. This is it. There's nothing we can do here. So let's also look at a word problem, 51, on the same page, 263.
So there wouldn't be a scenario where
Yes?
you would substitute, the e to the x minus negative x over 2 to kind of combine and simplify? Or is
Not
it
if it's,
simpler to?
it's a very good question. Not if there is no requirement, but you need to remember what they represent. Yes. Yes. E to the x minus e to negative x, and the other one is e to the x plus e to negative x, everything over 2. Yes. You should remember what they are. that's how they were determined, and they were given an arbitrary name, which is hyperbolic sine. Only because everything worked, like sine squared plus cosine squared, and so on as hyperbolic cosine squared. And there is a big theory behind it.
So we're not substituting the e to the x minus e to the x for these?
No. No. You cannot apply cosine to, I mean, all you can do, for example, is replace cosine 3x by e raised to 3x minus e raised to negative 3x divided by 2, but you can't simplify. There is nothing we can do. This. No, this is it.
So I guess what would we use the first definition for? The e to the x part.
That's how they were developed. We should know where they come from. Sine is the opposite over the hypotenuse, but hyperbolic sine is something else.
Well, I
It's
guess
a
I'm asking like what kind of problem would involve those using that function?
the e to the x, and here's one. 51 on page 263.
Got it.
So let's see. That specific, I may have to determine limits. So for example, when I want to determine the limit of a hyperbolic tangent, I either look at the graph or I look at the limit with replacing e to the x minus e to negative x over e to the x plus e to negative x to find the limit. Or I look at the graph. So the same thing with limit as x approaches infinity from hyperbolic sine. So I will replace hyperbolic sine by e to the x minus e to negative x over 2 and figure out what the limit is. So this is one example in which I will replace hyperbolic sine by what it means, really. But the beauty of this is because all these other, they're not, I didn't see them in here, but the beauty is that they act very similarly. So for example, we can determine, and we should do that, at least one example. Oh, here it is. So they prove it here, but they didn't show it anywhere. So hyperbolic cosine squared minus hyperbolic sine squared, we know that simple sine squared plus cosine squared is 1. But in this case, hyperbolic cosine squared minus hyperbolic sine squared is 1. So they do behave like trig functions behave. They're not trig functions, because trig functions are something else, right? They're ratios. But this is hyperbolic cosine is this, hyperbolic sine is this. But they ended up showing that hyperbolic cosine squared minus hyperbolic sine squared is 1. So they do act like they are trig functions, but they're not. So they have some similarities with trig functions. That's why they were named hyperbolic sine instead of something else, t of x. It seems what?
They should have made another name.
No, because they behave. Look at this. So this behaves kind of. If you remember, sine has to be truncated to make it into a inverse function. So this is quite similar to sine. This you can say, but this has nothing to do with cosine. I would have to agree, but it still has some similarities with cosine, because it's an even function like cosine is, and so on and so forth. Although cosine looks like a vase, right? So pretty similar, I would say. This, I mean, other than the fact that this is the horizontal asymptote is pi over 2, and this one is negative pi over 2, the similarities were striking with arctangent, actually, not tangent. So yeah, that's why they used, and it happens that they have a lot of properties that are similar to the properties of trig functions. So it was wisely done. Okay, 51. named, I would say. 51, let's see. But always please remember that hyperbolic sine, hyperbolic cosine, or all hyperbolic functions are based on which function? Exponential. Yes, e to the x, correct. Okay, a telephone line hangs between two poles, and they say 14 meters apart. In the shape of a catenary, which is 20 hyperbolic cosine x divided by 20 minus 15. So let's write this down. So y equals 20 hyperbolic cosine of x over 20 and minus 15. Perfect. Where x and y are measured in meters. So meters and meters. Fine. Find the slope of this curve when it meets the right pole, which means x equals 7 meters. Find the slope. So what do I have to find in order to find the slope? That's part A. Perfect. Thank you very much. I can't plug in if I don't have a function. Good. So I have 20. Hyperbolic cosine prime is, and of x divided by 20 times the inner function prime
Oh no, x over 20. Yeah.
the inner function prime is 1 over 20, and negative 15 prime is 0. So this y prime is hyperbolic sine of x divided by 20. We want to evaluate it when x is 7. So here's an example. Yes, please.
So where you have the y equals,
Yes.
there's two x's there. Is that supposed to be?
Oh, yes, of course. I'm sorry. Sorry. Thank you. My apologies. So I have not investigated if the calculator, you can and let me know, if the calculator has, because this is an example of exactly what Paul was asking. So when do I use that e to the x minus e to negative x over 2? So I don't know if the calculator has hyperbolic sine. If you find it, please let me know. But in between now and when you find it, I'm going to write e to 7 over 20 minus e to negative 7 over 20 and plug it in.
Yeah.
Okay, so here's an example. Okay, so that's fine. So I still would like to do this with the e because of the question that was raised, and it's a very legitimate question. So I have 0.5 in parentheses. You can do it with hyperbolic cosine. I'll do it by hand so I can show this is another way, in case you don't find it. So e to the x. So in parentheses, I have 7 divided by 20. Close the parenthesis. Minus e to the x.
Excuse me, where did the 0.5 come from?
It's 1 over 2,
Instead of dividing the whole thing by 2, you just multiply by 0.5.
right? Is that okay? 7 divided by 20.
Oh, you went back. Okay, yeah.
I went back to your question because it was a
Yep,
very
yep.
legitimate question to do this by hand. So here it is.
Yeah.
So
See what we're at?
I got 0.3571. So what did you get?
Way up there.
So what did you get with a hyperbolic cosine?
0.3517.
Perfect. So now let's look at part B. Paul, is this better? Is it clear what
Yes.
how we evaluate? So this is basically,
Would that be meters or meters squared? Or?
so this is the derivative. Very good question. Very good question. It has to have a ratio, right?
Meters per.
So the rate of change of, yes. So, yes, meters per meter, yes. Because y is measured in meters and x is measured in meters.
So we're saying meters.
So
Meters per meter.
Yeah. So horizontal meter, a vertical meter per horizontal meter. I will
Can we
write.
just say meters per meter?
Yes, but you have to understand that y is height and x, yes, yes, very good. Part B, find the angle theta between the line and the pole. So here it is.
And the line is the
This is the line.
tangent.
No, y prime of 7 is the tangent. Correct, correct. So this is the line and this is the pole. And this is the angle. Right? So imagine that this is the tangent line. So I need to determine this upper angle, but I will have to determine this angle first in order to determine that one. Subtract this one from 90 degrees to get this one. Because the slope of this line is this. So when I determine the angle I will be determining using the derivative, I will be determining this angle. But I really need this angle. So I will subtract whatever I get from 90 degrees. So theta, right, tangent theta equals 0.3571. I'm not going to call it theta, I'm going to call it theta 1 because this will be theta 1 and this will be theta that we are asked to find. We're asked to find this one.
It could be like alpha or beta or something.
Say it again.
I said it could also be like alpha or beta or something.
Yes, we can. We can use any other. Yes. It's just that I got lazy. I didn't want to erase it. I already wrote theta. So how do I determine theta 1, which is the base angle, this one? How do I determine theta 1?
You put tangent 0.3.
So what do I have to do to both sides when I solve this trig equation?
Take the inverse.
Exactly. Theta 1 is arc tangent 0.3571.
Right. I guess I'm missing, why is beta 2? Was that 2 or 1?
So the slope of this line gives us this angle, not this angle that we are asked to find. So I will find this one and subtract it from 90 degrees to find the angle that I'm looking for. So if this is the graph of a function, this line is y prime at x equals 7 in our case. And now we are asked to determine this angle. But the slope of this line gives us this angle, not this one.
So why do you call it tangent?
Because the tangent is nothing else but rise over run, which is the slope of the derivative, or the slope of the function at that point, which is the derivative at 7.
So you're saying that the slope represents tangent in this case. We're talking about
Correct.
Okay.
Yes.
Now I get
The slope that we just determined of this line is nothing else but the tangent of this angle.
Okay. Now
So in order to determine this angle, I have to find this angle first. Is that better?
Yep.
Perfect. So theta 1
19.65.
is your mode in degrees.
Yeah, chance of 2 degrees.
Okay, perfect. So perfect. So I go back to second and tangent of the previous answer. Yes, 19.656. 19.656 degrees. I'm sorry?
Yeah, you have to put radians in degrees before you can get any of the answers. And then you gotta change effective radians for everything else.
So from 90 degrees, I subtract the previous answer. So theta is 70.343. Is this okay? Any questions?
Maybe you just go back to the papers.
Any questions? What would you like to start reviewing for this test? So the checklist is due on Wednesday, and the test is a week from today. So what would you like to start with? We can start with this, or we can start with whatever you think we should emphasize more. Or we can start with this, and then every now and then you can say, I still would like to. Okay, very good. So this should take, the first page should take like 20 seconds. So let's do it. Okay, a minute.
Okay. You're learning to compromise.
1 minute.
Jim?
Do we have the answer for part A?
Y prime equals 2 times square root of x plus x to the third plus, and then plus 1 over 2.
Not plus. This is the chain rule. Please, the chain rule does not have any plus or minus.
Times
Yes?
1 over 2 squared, or 2 x squared, thank you, plus 3x plus
Careful.
-1, plus -1, or -1.
Y minus 1 over x squared. Very good. So as I said, just 20 seconds. Okay.
So we can stop there.
Yes, there is nothing we can do here. No, don't even bother. You can, if you simplify, you can maybe a little bit, but that's not the point here. Yes.
The test you're not going to want to see negative exponents.
Yes, that's true. But so that's why we remember the derivative of 1 over x is negative 1 over x squared. That's why we committed that to memory already. Yes, yes. Okay, part B, f prime.
Cosine 3x times negative, or no, times cosine x.
Francis?
I'm not done. I can't get to parentheses yet. I'm not done. When I differentiate sin 3x, I cannot get, I understand and I agree with that. So cosine x minus sin x, I agree. Minus,
Sin 3x.
yes, multiplied by,
Negative sin
yes,
x minus cosine x.
that's it, divided
Over
by,
cosine x minus sin x squared.
excellent. Don't try to do anything. It says no need to simplify. I only want to see it raw. So this is like 1 minute, really? 2, maybe? Okay. Moving on. So y prime. So what is this one?
3
Yes?
cosine
Yes?
squared
Yes?
e tan x, e to the tan x,
Good?
parentheses, times
Yes?
e tan x,
We're not there yet?
oh no,
Nope.
times
Sine.
cosine.
Times.
Negative sign.
Very good. Good. Times.
E
E to the
tan
tan.
squared
I agree. I agree.
C.
times secant squared.
No, now we're not there yet.
2.
Yes? Times.
Tan x.
I agree. Times.
Secant squared.
Awesome. There's nothing, I just, yes. Gina?
Where did the negative sign come from?
When I differentiate the inner function.
Uh,
So I bring down the power, I subtract 1 from the power, I differentiate the inner function, which is negative sine e to tangent squared, and then I differentiate e to tangent squared, which is e to tangent squared times the inner function prime, which is 2 times tangent times secant squared. Better?
Yeah.
Okay, very good. We did this problem in class, but we can do it again if you want. Okay. So f of x equals the square root of 1 minus x squared r cosine x. So f prime,
1 over
yes,
2
yes,
that times, yeah, 1 minus x squared times
Negative 2.
very good, times arc,
Cosine.
very good, plus,
Square root of 1 minus x.
very good, times,
arc cos.
This times or plus? Right, that's a plus.
so this is the first function times the first function prime times the second plus the first function times the second function prime.
Carry the plus over there.
Very good. So what is it? With negative, because it's r cosine, and it is 1 over, very good.
1 minus x.
That's it. So when we did this together, I said there is no point in simplifying. So this will be negative x arc cosine x over, or I should say plus, the square root of 1 minus x squared over the square root of 1 minus x squared. Because they have the same denominator. So leave this one alone, only simplify the two. They are both negative, so I pulled out a negative. So it's x arc cosine plus this. Does it make sense? Any questions? Negative 1 over the square root of 1 minus x squared. Not to be confused with hyperbolic sine or hyperbolic cosine. So the question is, what is the derivative of arc cosine? So the first function prime is this, times the second one plus the first one times the second function prime. Both functions have, so I simplified the 2 with the 2. Both functions have the same denominator. So the numerator here is negative x arc cosine, and the numerator here is the square root of 1 minus x squared. But since they're both negative, I put the negative in front. Does that make sense, or is it not clear? You want me to rewrite it?
I just don't see what the, like if I was just looking at the derivative of arc cosine, what's the answer to that?
Negative 1 over the square root of 1 minus x squared. Because I copied this here. So everything else is the derivative of arc cosine. Better? Good. Next problem. Hyperbolic sine squared applied to hyperbolic cosine.
2
Sorry about that. Yes.
2
Yes.
sin h
Yes.
cosine hx
Very good.
times cosine h squared.
Times sine. So 2 times sine times, yes, of course, I jumped myself.
Did I do something wrong?
No, you did not. You did not.
Use the white out.
Oh,
So it's 2 hyperbolic sine of hyperbolic cosine times the inner function prime, which is hyperbolic cosine of hyperbolic cosine, times the inner function prime, which is sine. So let me write it one more time so it's clear. 2 hyperbolic sine of hyperbolic cosine multiplied by hyperbolic cosine of hyperbolic cosine times hyperbolic sine x. Correct. Very good. Any questions? We did problem 2 in class together. We did problem 4 in class together. So let's move on to problem 3.
which one?
3.
Okay.
So let's take a look at f of x equals x squared minus 1 squared e to the x. Find f prime of x. Simplify the final form by factoring. Find the equation of the tangent line to the graph of f of x at the point 1, 0. So let's work on this. We want to find f prime, and we want to find the equation of the tangent line to the graph of f at 1, 0. So find the derivative first. Tell me what you get, and I'll write it down. Okay, so f prime
X squared times 2x
perfect.
times e to the x
Awesome.
plus parentheses 0x minus 1 squared
X squared minus 1 squared, yes,
e
times.
to the x.
Very good. Perfect. I recommend simplify this by factoring first.
What about the EX?
Not only.
And x
Squared
squared
x
minus
squared.
1.
Very good. Let's do that. So, x squared minus 1 times e to the x. And tell me what is left in parentheses.
2 plus 1. 3.
Not possible.
4x
4x from the first term plus
x squared minus 1.
x squared minus 1 from the second term. So we factored out x squared minus 1 and e to the x. From all this, x squared minus 1 is out, e to the x is out, so 2 times 2x is 4x. And then plus, 1 is out, e to the x is out, so x squared minus 1. So now we will plug in what? 1, indeed. 1, so let's plug in 1. So f prime of 1 is how much? 0. So we're asked to find y minus y1 equals the slope times x minus x1, where x1 is 1, y1 is 0, and m is 0. So what is this? Y equals? Y equals? Y equals 0. Is the slope of the tangent line to the graph of this function Very good. Another 1 minute problem, right? So let's work on 5. Differentiate and simplify completely. Ready? So we have f of y. We did this problem together in class. Y minus 1 to the 4th over y plus 2 to the 5th.
Number?
5.
Do you recommend changing it?
Say it again.
Do you recommend changing it to 5?
No. No. You could apply a natural log to both sides if that's what you want, but it's up to you. But no, I would not change it into a product. We had something similar on the checklist. But you do have to simplify it by factoring. That is crucial. And then I would like to, after we finish this, I would like to look at more problems from the book. Okay, ready? Can anyone dictate?
4
Correct.
parentheses y minus 1 to the 3rd times, well, I guess it'd just be 1.
Correct.
And then times y plus 2 to the 5th.
Perfect. All perfect so far.
Minus
Yes.
y minus 1 to the 4th
Perfect so far.
times 5y plus 2 to the 4th.
Perfect.
And then y plus 2 to the 10th, I guess, at the bottom.
Yes, so times y prime, which is 1. Perfect. Very good. Excellent. If you start simplifying something at this stage,
Make the y to the plus 2 to the 5th, make that 1, and then take away 5 from the bottom.
that's exactly what I was going to say. If at this stage you try to simplify this with this or this with this, I cannot give more than 0 points. Because you would be simplifying portions of terms with a factor. That's why we have to simplify. Yes. You have to simplify by factoring. So please be very careful. We cannot do that. So let me explain again. So if I have 2 times x plus 3 divided by x, can I simplify this x with this x? No, because x is not a factor in the numerator. It is in the denominator, but it's not a factor in the numerator. So we cannot do that. Okay, perfect. So then find the least common, the greatest common factor.
Y minus 1 to the 3rd.
Y minus 1 to the 3rd, I agree.
And then y plus 2 to the 4th.
I completely agree. Now let's see what is left, and I copy the denominator. And now I can do this because I simplified the factor from the top with the factor from the bottom. So What is left?
4
Yes, a 4 is left.
times
Y plus 2.
y
1 y plus 2 in parentheses. I reached the minus now.
minus
Yes?
5,
Perfect.
Y minus 1.
And y minus 1 indeed in parentheses. Perfect. Excellent. So then y minus 1 to the third, and then I have here 4y plus 8 minus 5y plus 5. 4y minus 5 is negative y, and 8 plus 5 is 13. And yes, I would prefer seeing this, please, although you will get full credit for this, but I need to see this. Please. No negative leading coefficients. You will see in chapter 4 why.
So you can pull the negative out of the negative y plus 15.
Yes. Is this okay, everyone? Yes. What is he listening to? What kind of music can you?
I'm not listening to anything.
Oh, okay. I thought you were. That's fine. That's fine. No, I need to know what my students listening to, because that's how I broaden my horizon in music. I always ask, what are you listening to? What is, you know, new?
You don't.
I do want to. I absolutely want